Okay, let's move into this last section, which is 1.6. So we're dealing with special functions. We're really just going to look at a couple of different things. And then we get into even more special functions. I'm not sure why they just call this one special functions, but this is 1.6, and then we will be done with module 1 soon. So, of course, we go to launch presentation and get into first the vocabulary. So, what are we looking at in the vocabulary? Piecewise, um, a step function. We're not going to deal with greatest integer functions. We're going to look at absolute value, and we're going to look at parent functions. And instead of describing them here, I'm just going to let you kind of look at all the definitions because we'll see them as we go through all of the different slides. So a piecewise function is defined by two subfunctions. So maybe it doesn't describe it very well. So anyway, so we're going to look at this piecewise function. So a piecewise function is something like this, and we have talked about it a little bit just because we were looking at discrete functions. So if we have something like this, and we have, let's say a line that goes up to this point, then we have this part, and this goes to here, and then we have another one which comes down here, and then maybe goes like that. I don't know, something like that. But that's piecewise because you'll see at a certain x value, in both cases, it jumps or it falls. So it does something like that. So they're not connected. So this is neither discrete nor continuous because of how it looks here. So that's what we're looking at with a piecewise function. And then a step function is just a specialty piecewise function. So it's going to look like this. So it might have a starting point, go up to here, have another point, go up to here, have another point, go over to here, have another point, go over here. So it looks like a step. So it looks like steps that we are taking up there. Absolute value function, and then a parent function we'll talk about. So an absolute value function is going to look something like this. Now, I'm going to actually do both at the same time. So this is an absolute value function and a parent function. So the absolute value function is something like this: y equals the absolute value of x. This is what is known as a parent function. So eventually we're going to understand how to shift that parent function around to do something a little bit different. But the function itself goes through 1, 1 and negative 1, 1. And so this is an absolute value function. And the parent function, the reason why it's parent function is because there's nothing multiplying anything here or adding anything here. So, eventually we're going to be graphing something like this. So we'll take a look at something like that. So that's what's happening. So the parent function is the one that's the original function, usually located at the origin, and then this one shifts around. So there's things that happen. It goes up for, there might be a number inside here as well, -1. So then it's going to go to the left a certain number. It's going to either go up faster, it's going to go up slower. So there's all kinds of things that we start doing once we start dealing with it becoming a little bit more complicated. So parent function, absolute function, that's what it's going to look like in this case. Of course, if the absolute value function is negative on the outside of the absolute values, then this is going to go down instead of going up. Okay. So graphing them here is, you'll notice here that we have x plus 1 is the function before x is -1. So this part right here is x plus 1. And then we have -1/3 x plus 10/3 if x is greater than -1. So anywhere beyond this point to the right. This function right here has a slope of a -1/3. That's why the line is going down. And plus 10/3 tells me where it's actually crossing the y-axis, because remember this is the y-intercept. So, and notice this one has a y-intercept. It never hits it because it's always less than or equal to -1. But if this were to keep going, it would actually hit that particular point. So it just kind of gives me some information. You can see that on here, and this one kind of gives me some information here. Okay, so what is the domain? So since it's running all the way to -infinity to the left, that means the domain is -infinity to +infinity, and it includes all points. Of course, one has to be open, one has to be closed. Basically, only one can be a closed circle if I have multiple points here, because, of course, it's a function. So a function has to only have one y value, so I have to be careful there. So that's the domain. Is it continuous? No, it's not continuous, and it's also not discrete. It's neither. Okay, because it's a little bit of a mix of both. We can take a look at the answers, and so we can see that here. Okay, go to the next one, and we will start graphing things. Okay, so the graph of the function is x minus 3 if x is less than or equal to 1. So first thing that we're going to do is we are going to graph x minus 3. I think it's going to bring up a graph for me. Yep, so when x is less than 1, so here is x is 1, so everything to the left of that is going to be it. Of course, we can see here that my intercept is -3, which is right there, and we can see that my slope is 1. So if I go here to -3, and then I go up 1 over 1, that would be that point, and then we could draw the line. Okay, so we can see what that is. Okay, so that is that one. And I think that's the first part. So step number 2 says that now we're gonna do the other side. The other side is 2x when x is greater than 1. So here's 1 when it's to the right of that value. If I plug in some numbers, or I just look at the slope. So this does have an intercept. Of course, the intercept is 0. So I could draw the line from here and at least draw it all the way back and through that particular point, because it has to go up 2 over 1. And then eventually I would just erase this part because that's not part of the actual function. Notice that in this case that there is no equal sign, so that is not a closed circle. In the first one, there is an equal sign. That's why it is, I'm sorry, it's an open circle in the second one. It's a closed circle here because of the equal sign, and an open circle because it does not have an equal sign. Okay, so that's what it looks like. Analyze any key features. We really don't have to analyze anything. Okay, we know all this stuff about intercepts and everything else. And of course, there is no x-intercept for this particular function as we're looking at it. Okay, let's go ahead and graph our own. I'm thinking, oh, it's already graphed. So we're going to take a look at this one in the middle. So between -2 and +2, it has to equal 3. So here is x is -2, here's x is +2, y is equal to 3, y is equal to 3. This isn't even a function. So, and the reason why it's not a function, because if I draw a vertical line through any of those points, so D is completely eliminated. So it's either A, B, or C. Okay, just based on looking at the 3. Okay, this tells me that the slope is 1/2 when x is less than -2. So anywhere beyond to the left of this, we have 1/2. So let's say we start at this point right here. We go up 1 over 2, that's fine. Up 1 over 2, that's fine. And this one we go up 1 over 2, that's fine. So all of these have a slope of 1/2. So that's going to work. That any one of those can still work. But notice here, do we have any other information that I know? We know that it's less than, so therefore it has to be an open circle. So it either has to be B or C. So one of the two. Excuse me. And so now we're going to take a look at the last one. So it's either B or C. So now we're going to take a look at this one right here. This tells me it's a negative slope, and it's greater than 2, which means it does not include 2. So this one includes 2, this one does not. So therefore it has to be C. So we're going to check our answer. And why is that? It has to be greater than 2, not equal to. But that one, oh, and why? And I made a mistake here. Notice here, this one is equal to, but this one is not. So therefore it actually should have been D. I'm sorry, B. My goodness. Okay, so it should be B because it's equal to. I should have really checked both of those. I was a little careless there. And just be careful on those. Okay, so it should be B. Okay, so what is the domain? The domain, if we look at this function, which is this one, runs all the way from negative infinity to positive infinity, so it's all real numbers. And the range runs from down below all the way up. And notice that the range goes up as high as 3, so it's from negative infinity to 3, so it has to be less than 3. Less than or equal to 3. And the reason why less than or equal to, because of that solid line. Okay, so that should be okay. It's a little bit more careful watching those, so, of course, always be careful using those. Modeling by using a piecewise defined function. So this just gives you an idea of the different uniforms. So notice here that we have 0 to 5 jerseys. It's going to cost us $88. So notice here, between 0 and 5, it's 88. Between 5 and 11, it's 75. Between 11 and 29, it's 65. And then if we order, what does it say here? So it's $56 when there's 30 or more. So when there's more than 30, so more than 30 would be x is greater than 29. So we're going to bring that one down here and put one in there, and we're okay. So we're just kind of checking. So what would it cost to purchase 11 jerseys? So if we want 11 jerseys, it would be 11 times 75. Okay, so it'd be 11 times 75, whatever that number is. And for 25 jerseys, it would be 25 times 65. Okay, so that's what we'd be looking at. And then the last one says evaluate f of 29. So that just says if there's 29 jerseys. So at 29 jerseys, it would be this one, not this one, because that's the equal sign. So it'd be 29 times 65. And then we get our answer here. Okay, so that's what we're looking at on those particular numbers. Okay, and I think we're looking at graphing again. I think you understand the idea of how to graph those particular ones. All those other ones were lines. Oh, and this is the check. So that's what you're going to be doing next.